Hi everyone, this is me Shivani here, back with a very beautiful chapter of +1 chemistry. And what is a chapter? Which is a chapter? Chapter is classification of elements and periodicity of elements, periodicity in properties. So you guys know what is a periodic table is, right? What is a periodic table? What are the elements? Maybe from class 8 onwards, you may be familiarizing with the subject of chemistry, right? You'll be studying chemistry from class 8. Probably in my case, I started studying chemistry from class 8. And during those days in class 8 and 9, chemistry, physics and biology were entirely a textbook. The first part will be physics, second part will be chemistry, and the third part will be biology. I don't know in your case, what is it? It's having different textbooks, or it is in a one single textbook. Okay, that was my step to the world of chemistry. So those days, I started studying periodic table, the elements in it step by step. I started studying each and every element. So during those days, periodic table is just a table for me. Okay, having lot many elements in it, full of colors, right? Red, green, yellow, full of colored. A colored table actually, a multicolored table. Nothing much. Okay, nothing much. But at this point of life, when I teach you chemistry and when you guys are in class 11, to know more about periodic table and the elements in it, to know the history of periodic table, you should know that periodic table is just not the colored, a multicolored table, but behind a table, behind just a table, there are lots of work by lots of scientists. Okay, a lot of inventions, a lot of researchers, led by a lot of researchers. Okay, so that is something that paved way to the present form of periodic table which we use in chemistry, that is a long form of periodic table. So in this chapter, the classification of elements and periodicity in properties, we are going to deal with how elements are classified usually from the very beginning of chemistry, from the beginning of world. How were elements classified during those stages by many of the scientists, and whether those classifications were possible, were success or failure or not, and how it led to the present form of periodic table which we use in chemistry right now, that is a long form of periodic table. Let's see those classifications and the first periodic table which led to the table which we use now, and for the classifications in periodic table. Okay, so first we should know what is a periodic table. What is a periodic table? From class 8 onwards, I started knowing periodic table, and as I already mentioned, in those days, periodic table was just a multicolored table for me, which I use in chemistry. Nothing much, because at that stage, we don't want to know much about periodic table, right? But today, when I teach you, when you guys are in +1, you need to know more about the periodic table. Okay, so periodic table is actually a arrangement. What arrangement? What sort of arrangement? A systematic arrangement. Systematic arrangement of what? Of elements, of various elements. According to what? On what basis they are systematically classified? They are classified on the basis of their properties. In what form? In a tabular form. So periodic table is actually a table consisting of lot of elements like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, etc., etc., etc. So it consists of lot of elements, and it is classified systematically based on their properties. Into what? Into a tabular form. They are classified systematically and made into a tabular form. So that is a periodic table. Now, why do we need a periodic table? As I already mentioned, many scientists had undergone many researches, many studies about the elements in periodic table, or the elements then and now, and finally we came to a conclusion that we are actually not complete in the process of finding elements. We are actually going on finding elements new and new in the coming years, right? So at present we have 118 elements, as already mentioned here. Yeah, 118 elements are there, but in those 118 elements there are many man-made elements as well. So these researches for finding new elements is not complete at this point of stage. It's ongoing. Many researchers are ongoing to find new elements, to invent new elements, to understand new elements, right? So we need a periodic table to understand those elements in detail. When you were in your smaller classes like 3rd standard or 4th standard, you were able to understand multiplication. How were you taught? How did you learn about the multiplication? How did the teachers teach you about multiplication? They taught you like study the multiplication table of 1 for today, and tomorrow you will study the multiplication table of 2. So the multiplication table of 1 will be like 1 into 1, 1 into 2, 1 into 3, 1 into 4, and the multiplication table of 2 will be like 2 into 1, 2 into 2, 2 into 3, 2 into 4, 2 into 5, right? So it was easy for you in those days to learn multiplication, to know about multiplication, as it was classified, as the multiplication table is classified into 1, into 2, into the multiplication table of 3 and the 4, etc. So it was classified and the study was made easier to you. So for that purpose, we use periodic table to have an easier learning of the elements in periodic table. We have periodic table to have an easier learning of the elements. Number of discovered elements are 118 now at present. Many researchers are going to develop new elements. As we already know, things are changing. So the elements that could be found out in later stage is also predictable, right? Can also be there. As the data is increasing enormously, it is difficult to study the properties of elements, right? At present there are 118 elements, and many elements will come in the near future. So the study is getting difficult day by day. The study of elements, the study of the properties, the study of the characteristics is getting difficult day by day. To reduce the difficulty level, to make it easy, we have classified the elements into different sections, and studying the properties of that section is equal to studying the properties of each element. So for that easiness, we have periodic table. Now, before coming to the periodic table that we use now, there were many scientists who had led many researches, and many were able to classify elements into different categories. And one such as the classification of elements into metals and non-metals by Lavoisier. Lavoisier, a scientist, has classified elements in periodic table into metals and non-metals. But that classification is it worthy? No, it is actually a failure, because we know that in periodic table there are metalloids as well. Not only metals, not only the non-metals, but also metalloids are there. Metalloids are present in periodic table. So Lavoisier has classified into metals and non-metals, but metalloids were just excluded. Okay, he was like, okay, I don't know what metalloids are. I didn't see any metalloids, just metals and non-metals. But that classification is a failure. So Dobrena, the next scientist, he has classified the elements into group of three, and that is called triads. So Dobrena has a law based on which he classified elements, and that law is called law of triads. What does the law of triad state? Law of triads states that when three elements are arranged in the increasing order of the atomic mass, okay, when three elements are arranged in the increasing order of atomic mass, the atomic mass of middle element is actually the arithmetic mean of the first and the last element. For example, I take X, Y, Z, three elements, okay, having the three elements are placed in the increasing order of atomic mass. X, Y, Z are the elements. When I add the atomic mass of X with atomic mass of Z and divided by 2 means I am taking the mean, or I am taking the average, I get the atomic mass of Y. This is what the law of triad states. Okay, so law of triad states that when three elements are called a group of three, which means a triad. When I take a triad, in which the elements are arranged in a increasing order of atomic mass. The atomic mass of the middle element is actually the arithmetic mean of the first and last element. Hope it's clear. One example is given here, lithium, sodium and potassium. When I add the atomic mass of lithium and potassium and divide it by 2, or I take the mean, I get the atomic mass of sodium. But this law, the law of triads, is actually a failure because because the scientist was not able to depict all the elements according to that. He wasn't able to arrange all the elements according to that law, the law of triads. Now Newlands, another scientist, is here with law of octaves. Law of octave. Law of triads means a group of 3. What about law of octave? Oct means what? 8. Yes. Law of octaves. In law of octaves, Newlands states that when I arrange 8 elements in the increasing order of atomic mass, I was able to see that every first element showed similar property to that of the 8th element. Like 8th note in octave of music. What is octave of music? Octave of music means what? Sa, Re, Ga, Ma, Pa, Da, Ni, Sa. The first Sa and the last Sa, they are same, they are similar, right? So like that, like the octave of music, like the 8th note in octave of music, when I arranged 8 elements, when Newlands arranged 8 elements in the increasing order of atomic mass, he was able to see that the first element showed similar property to that of the 8th element. Okay? And example is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium. From this, the lithium and sodium showed similar properties. Okay, the first and the last element showed similar properties when 8 elements were arranged in the increasing order of atomic mass. But the thing is that he was not able to explain, or he was not able to bring this law of octaves to every element, mainly element beyond calcium. Those are heavier elements. He was not able to bring or substitute this law in elements, bring this law in elements heavier than calcium, or heavier elements, or the elements coming after calcium. He was unable to show this law as true, this law is valid. So ultimately this law fails, right? So when noble gases were introduced, he was not able to prove it as a right law, valid, an apt law. He failed to show that the law is valid when noble gases were found out. When elements beyond calcium were found out, the law terribly failed. Lothermeyer's curve of atomic volume versus atomic mass. So it's actually a graph. Lothermeyer plotted a graph in which the coordinate axes were atomic volume and atomic mass. When he plotted the curve, he found out that many of the elements occupied similar space, similar position in the curve. So it was very sure from that curve itself that the elements which occupied similar position had similar properties. Okay, that's what Lothermeyer's curve tells us. He observed that elements with similar properties occupied similar positions in the graph. Now Mendelev's periodic table. Who is Mendeleev actually? Have you learned about the Mendelev's periodic table before? Have you seen Mendelev's periodic table before? Mendeleev is actually known as the father of periodic table. The father of periodic table. Mendeleev is actually the father of periodic table. Because why is he called the father of periodic table? Let's look on to the features of Mendelev's periodic table, and the features of Mendelev's periodic table is itself the reason for why he is called as the father of periodic table. So Mendelev's periodic table, some merits are given here. He introduced tabular format. For the first time in the history of chemistry, he introduced a tabular format to classify elements very systematically. He undergone a systematic study of elements, and he classified elements very systematically into a tabular format. Very important point. When you're asked to write about Mendeleev's periodic table, the merits of Mendeleev's periodic table, the features, you should write that he was able to undergo a very systematic study about the elements, and also he was able to systematically classify the elements into a tabular format. As the table consists of rows and columns, consider this as a periodic table in which the horizontal rows are called actually series. In present form of periodic table, we call this horizontal rows as what? Periods. Yes, periods. And the vertical columns are called groups. And in present form of periodic table, we call the vertical columns as groups itself. But the name is different for periods. In Mendeleev's periodic table, periods are actually called as series. Series means horizontal rows. Now, prediction of new elements. He was able to predict new elements like aluminium, which had an atomic mass of 70, and also he predicted the presence of silicon, which had the atomic mass of 72.6. So in those days, when he introduced a periodic table like Mendeleev's periodic table, he was even able to predict the presence of some elements which are not there in the periodic table at that time, and he called them as aluminium and silicon. He also predicted the atomic mass like 70 and 72.6 each respectively, and later these elements were called gallium and germanium. Later we came to know that his prediction was right, and we named it as gallium and germanium. Why aluminium? Aluminium means there is an element having similar properties to that of aluminium. He also predicted the presence of silicon. He said that there is an element in periodic table which is not there right now. There will be which is having properties similar to that of silicon. He was also able to correct the atomic masses of certain elements. Certain elements like platinum, gold, beryllium. He was also able to correct the atomic masses of certain elements like platinum, gold and beryllium. Now coming to Mendeleev's periodic law. As Mendeleev created a periodic table, he must have followed a law, right? A law along throughout the creation of the periodic table. He must have followed a law, and that law is called Mendeleev's periodic law. What this Mendeleev's periodic law states? The properties of elements are periodic function of their atomic weights. He followed Mendeleev's periodic law throughout the creation of Mendeleev's periodic table. He arranged the elements in the increasing order of atomic mass or atomic weight. Atomic mass or atomic weight. He created the table such that the elements are arranged in the increasing order of atomic weight or atomic mass. Hence, the properties of elements depend on the periodicity in atomic weight. So that is Mendeleev's periodic law. Now coming to demerits. Demerits in periodic table of Mendeleev. No proper position for hydrogen was given. He was not able to give a proper position for hydrogen. Chemically similar elements were kept in different groups, and chemically dissimilar elements were kept in same group. So it's actually a buy one get one, because chemically similar elements were kept in different groups, and chemically dissimilar elements, no chemical match, such elements were kept in same group. Also, the increasing order of atomic mass isn't followed properly. As I already told you that the Mendeleev's periodic table follows the increasing order of atomic mass. Elements were arranged in the increasing order of atomic mass, but this increasing order of atomic mass isn't followed properly throughout the periodic table. Now, the modern periodic table. Modern periodic table by Henry Moseley. Henry Moseley. Henry Moseley proposed the modern periodic law, and based on modern periodic law, he created modern periodic table. Let's see what is that modern periodic law. The physical and chemical properties of elements are periodic functions of atomic numbers. Atomic numbers. So, he created a long form periodic table. Okay, this modern periodic table is also called as long form periodic table. Long form periodic table, which is in use at present. So, he created the table by following the modern periodic law. In modern periodic law, the properties of elements depend on the periodicity in atomic numbers, not atomic mass, but depends on atomic number. Means what? He arranged the elements in increasing order of atomic numbers in periodic table. In his periodic table, in Henry Moseley's modern periodic table or long form periodic table, he arranged elements in the increasing order of atomic number. Hence, the properties depend on the periodicity in atomic number. Yes. Periodicity. What is periodicity? Periodicity means, let me write a sequence in maths. 2, 4, 6, 8, 10. These are even numbers, I know. But see, between 2 and 4, there is a gap of 2. Between 2 and 6, there is a difference of 2. Between 6 and 8, there is a difference of 2. So, it maintains a periodicity. The same periodicity is seen in chemical, the periodic table. The same periodicity is seen in periodic table between elements. So, periodicity means when properties recur after regular intervals. They repeat after regular intervals. We say there is a periodicity in periodic table. Periodicity, when elements were arranged in increasing order of, this is very important, when increasing order of atomic number. When Henry Moseley arranged the elements in increasing order of atomic number in his periodic table, we can see that elements with similar properties recur after regular intervals. The same property, the similar properties are recurring after regular intervals. So, such a tendency is known as the periodicity. Periodicity. Now, elements in same group have same what? In Henry Moseley's modern periodic table or the long form periodic table, elements in same group have same what? Same what? Elements in same group have same property. Yes. Property. Horizontal rows are called, same as Mendeleev's periodic table, horizontal rows are called periods. And vertical columns are called groups. Number of groups, there are 18 groups. Number of periods, there are 7 periods. You are already familiar with these things because you have studied the periodic table. You might have familiarized yourselves with the periodic table in your previous classes. Number of blocks, there are 4 blocks. 4 blocks in periodic table. You might have learned about the blocks in your 10th standard, right? Number of blocks. And which are those blocks? S, P, D, F. So, there are 4 blocks in periodic table. They are S, P, D, F. Groups coming under specified block. In S block, P block, D block, F block. S block we have first and second group. In P block we have 13 to 18th group. As there are 18 groups, the first and second groups come under S block. The 13th to 18th group come under P block. D block means it is actually 3 to 12. 3rd to 12th group come under D block, and F block is actually lanthanoids and actinoids. The F block is actually an extension of P block, okay? F block is actually an extension of P block. You might have seen the F block at the lower part of the periodic table. I show you. In lower part of the periodic table, you will be able to see the F block. So, this is the periodic table which we are using at present. And so, The first two groups are called S block. First and second groups are called S block. The 13th to 18th groups are called P block. P block. And the 3 to 12 groups are called D block. And the last, the lanthanoids and actinoids. This is lanthanoids and this is actinoids. They are called as F block. F block. Okay, that's clear. And the S block and P block in collective, okay, in together they are called representative elements. Representative elements, S and P block elements excluding the noble gases. Noble gases are group 18 elements, okay. S and P block elements excluding the 18th group elements. 18th group elements, which are known as noble gases. 18th group elements are called noble gases. They are called as representative elements. And the D block elements are called transition elements. D block elements are called transition elements. S and P block elements excluding the noble gases or inert gases or 18th group elements are called representative elements. And the F block elements are called inner transition elements because the F block elements are a part of the period 7, 6 and 7. Period 6, this is actually period 6, this is period 7, okay. So, lanthanoids and actinoids are actually an extended version of the period 6 and period 7. They are called inner transition elements. Inner transition elements. So, this is all about the periodic table that we use at present. Now, we have to know about the S block, the D block, the P block, the F block in detail. Also, we need to know how to name the elements after 100, after the atomic number 100. Till 100, the names are already fixed, and after 100, we should have a method to name the elements, and that method is put forward by IUPAC, International Union for Pure and Applied Chemistry. Those things we'll discuss in the next session. Till then, bye.